Hello, this is a help video. I'm going to go over 3 examples to help you understand when would your inequality be always true, never true, or so. Okay, so for all of these, what you need to do is simplify the inequality, and then you're going to look at your final statement and decide if it's sometimes true, never, or always. So let's do a couple examples. I have negative 2 times 3x plus 1 is greater than negative 6x plus 7. So I'm going to simplify this as much as possible, and then we'll make the determination which one applies. So I have some like terms. We have a 6x and a 3x. I can't combine those though because the parentheses are in my way. These parentheses are telling me that negative 2 needs to be multiplied by everything inside, so I'm going to distribute that. So I'm doing negative 2 times 3x and negative 2 times 1. We'll go ahead and do that multiplication there. Okay. So now we've got our like terms, negative 6x and negative 6x. I want to combine those to simplify here, but they're on separate sides of the inequality symbol, so I'm going to move one to the other side. When we are moving a term from one side to another, we do the inverse operation. This is subtract, so I'm going to add, because that gives me a 0 here, and by coincidence, it also gives me a 0 here. So that leaves me with negative 2 is greater than 7. So simplified as much as possible, you need to ask yourself, is the value of negative 2 greater than 7? Is that a true statement? And it is not. 7 is a higher value than negative 2. If you take a look at where they are on the number line, seven is further to the right. It's a higher, larger value. So 7 is greater than negative 2, not the other way around. So notice also there's no variables here. So there's nothing left that is going to change my values. This is always going to be a negative 2, and this is always going to be a 7. So it's never true, okay? We canceled out our variables on both sides. Let's look at another example. I'll show you another one where the variable is going to cancel, okay? Five times 2x minus 3 minus 7x is less than or equal to 3x plus 8. So we've got like terms, but we can't combine them. We have parentheses. We're simplifying. We want to follow our order of operations. Trick for that is PEMDAS, right? Parentheses and exponents first, then multiply, divide, then add and subtract. So I have some parentheses to take care of. Inside the parentheses is 2x minus 3. Those are not like terms. I can't combine them. Those parentheses instead are there to show me that it's 5 times this and that. So let's distribute. This 5 is a positive 5. And then I just bring the rest down. Okay, so that'll give me 10x minus 15 minus 7x is less than or equal to 3x plus 8. I have like terms that are on the same side of the inequality symbol, so I can go ahead and combine those. Remember, they're like terms because they have the same variable and the same exponent, both x's. 10x minus 7x is 3x. Okay, I want to continue to combine my like terms, except that they're on opposite sides of the inequality symbol. These are positive 3x's, so I'm going to just move this one over to the other side. Just like our last problem, 3x minus 3x is 0 that happens on both sides. So I get negative 15 is less than or equal to 8. So is that a true statement? 8 is over here. on the positive side, negative 15 is going to be over here. 8 is further to the right on the number line. It's a bigger value, right? You'd rather have someone give you $8 than take 15 away. It's a greater value. And this statement is true. Okay, and it's going to always be true because like our last problem, our last example, the variables have canceled. So there's nothing that's going to change. I'm not going to substitute any numbers that are going to be different. This statement is always negative 15 is less than or equal to 8, and that's always true. So let's do one example. What happens if your variables don't cancel out? Okay, so again, general rules, we're simplifying as much as possible. Look at the final statement. If it's a true statement, then it's true. If it's false statement, then it's never true. Let's see what happens if we don't cancel our variables. Okay, similar setup. Let's simplify by distributing. It's a positive 6. So positive 6 times 2x, positive 6 times negative 1. Oops, I'm going to erase the problem here. Okay, I want to combine like terms. This is a positive 3x. I'm going to minus 3x will give me 0 here. If you do it on one side, you need to do it on the other. But in this case, 12x minus 3x gives me 9x. Okay, and then I've got 12 and this negative 6 are like terms. Let's get those together. So that's going to be 0. 12 plus 6 is 18. This is 9 times x. To undo it, I divide, because 9 divided by 9 is just 1. And we get x is greater than 18 divided by 9 is 2. Okay? Now, in this case, this is where we have our sometimes true. Sometimes it's going to depend on what our x value is going to be. So you need more information. If I say x equals 6, then we'll have 6 is greater than 2. That's true. But if we have an instance where we say, okay, x equals 0, that would give us 0 is greater than 2, which is not true. So you're going to have this sometimes when you have a variable that is going to be changing the statement depending on what that variable represents. All right, so those are some 3 examples. You'll find more in your notes posted for the lesson as well.